Let us start the question. Verify Rolle's theorem for the function. This is the given function in the interval -4, 2. Students, we have 3 steps here. So step 1, so if you follow the steps, you will get good marks, absolute marks in the board exams, whatever you are writing. So step 1 is, see, if you just observe, the given function is a quadratic function. So all polynomial functions are continuous with respect to its domain. So we can say given polynomial function in bracket quadratic function is continuous and differentiable in the given domain, in the given interval, we can say. So this is the first step of Rolle's theorem. Step 2, verify f of a is equal to f of b. Verify whether this is valid or not. So let us see that. So we know a is equal to -4, b is equal to 2. So and f of x is given by x square plus 2x minus 8. So this implies f of -4 is equal to 16, -4 whole square is 16, minus 8, minus 8, so which is 0. Now we will check f of b. So f of 2 will be 2 square is 4, plus 2 2s are 4, minus 8 is equal to 0. So this implies f of a is equal to f of b. This is verified. Step 3 is find f dash x. Take the given function. F of x is equal to x square plus 2x minus 8. So f dash x can be written as 2x plus 2, students. So this implies f dash c is equal to 2c plus 2. Please recall what is the formula for Rolle's theorem. The final formula for Rolle's theorem will be f dash c is equal to 0. Step 3 will continue as it is. So when f dash c is equal to 0, we need to find the value of c. So this is the condition for Rolle's theorem. So 2c plus 2 is equal to 0. So 2c is equal to -2, c is equal to -1, and this -1 belongs to -4, 2. So this implies Rolle's theorem is valid or verified, whatever you can write. Rolle's theorem is valid or verified. This will be normally a 3-mark question in your board exams. Please make a note of it. So what is the step 1? The given polynomial function, which is a quadratic function, is continuous and differentiable in the given domain, continuous and differentiable in the given interval. Also, step 2, verify f of a is equal to f of b. If this does not satisfy, then stop there. In this problem it is satisfied, getting 0 as both. Then you can continue to step 3, find f dash x. After that, find c when f dash c is equal to 0. Very simple function they have given. So this is a quadratic function. So these are the given values, the given intervals. So write the step 1 as it is. Given polynomial function in bracket quadratic function is continuous and differentiable in the given interval. Step 2, verify f of a is equal to f of b. So take the a value, students. So first let me write f of x f of x is equal to x square plus 2. See, f of x and y both are same, there is no difference. F of x is the output, y is also the output. So y is the vertical value, x is the horizontal value. Okay. Also we say this is the independent variable, x is the independent variable, y is the dependent variable which is depending on x. So f of x and y are same. So a is equal to minus 2, so f of a is equal to f of minus 2, which will give me 2 square minus 2 whole square is 4 plus 2 6. F of b, same thing I am going to get, f of 2 4 plus 2 will be 6. So this is step 2. Go to step 3 directly. So step 3 is find f dash x. F of x is equal to x square plus 2. This implies f dash x is equal to 2x plus 0. This implies f dash c. So I am taking x as c as per the Rolle's theorem, that is the variable they have used in the definition c. Now step 3 continued. When f dash c is equal to 0, 2c is equal to 0, c is equal to 0 by 2, 0 by any numerical value, positive or negative, will be equal to 0. So 0 belongs to the given interval minus 2 comma 2. So we can say Rolle's theorem is verified. Simple problem, make a note of it. Yeah, students, examine if Rolle's theorem is applicable for f of x is equal to box x. So this is also called as greatest integer function. Greatest integer function for x belonging to 5 comma 9. Now students, we already know greatest integer function is not a continuous function. So it is discontinuous at the integer points. So because it is discontinuous, it is not continuous, Rolle's theorem is invalid. Straight away we can write. If it is a 1 mark problem, you say directly, if it is 1 mark, if the question is for 1 mark, you say f of x is equal to box x is discontinuous function. Is discontinuous function. It is discontinuous at integer points. So Rolle's theorem is invalid or cannot be verified, okay, for this function. So if it is a 1 mark question, you have to write it. What if it is a 3 mark question? Then you have to take one value in between 5 and 9 and show at that particular value it is discontinuous. Now, so for 3 marks I will do it. So let me take a value. So this is for 3 mark. So let x is equal to 6. It is in between 5 and 9. So now at x is equal to 6, I am going to do the left hand limit, students. Left hand limit will be x less than 6. See, whenever we are doing limits, so this is the 6. Left hand limit means I am coming from the left hand side. So that means the meaning of limit is approaching value or the tending value or the value at the nearest neighborhood. That is the meaning of limit. So whenever I say x is approaching 6 from the left hand side, it is not becoming 6 first of all. It is almost equal to 6. So you have to fill it. So we can say 5.99999, you know, for entire day you can say 5.9999999, like that it will go. Now, so limit of x approaching 6. So what will be the value of box x? So let us discuss that also. If I put 5.99999 etc., so what will be the box value or the greatest integer value? 5.9999 will be equal to 5. So please understand this. It is not 6, 5.99. The greatest integer value is 5. So I am going to write 5 here. Left hand limit x less than 6 will be limit of 5 x approaching 6. So limit of a constant is constant only. The answer is 5. Now right hand limit I will take x greater than 6. So that means I am approaching from the right hand side towards 6, right? So from right hand side if I am coming means the nearest value it can take will be 6.000001 etc. 6.00001. So what will be the box value, greatest integer value of this? So this value is 6, if people know it. So limit of 6 x approaching 6 will be equal to 6. So we can conclude left hand limit not equal to right hand limit. So this implies f of x is not continuous at x is equal to 6. Also we can write similarly at all integer points f of x is not continuous. So this implies Rolle's theorem cannot be applied. Cannot be applied or invalid, because this given function is discontinuous function. So this you have to write if it is a 3-mark question. For 1 mark, this statement is enough. Make a note of this, students. Now it is a similar problem. The function is same, but the interval they have changed. In the NCERT, they have just changed the interval. Same logic. F of x is equal to box x is discontinuous function. It is discontinuous at integer points. So the Rolle's theorem is invalid. Stop here. If it is 1 mark, stop here. For 3 mark or 4 mark or 5 mark, we have to do certain steps. Let it take x some point between -2 and 2. Any point you want. You can take -2 and 2. So let me take 0 as the point. No issues. So at x equal to 0. So LHL is x less than 0. Now students, when x is less than 0, it is coming from this side. X is less than 0, it is coming from this side. So what will be the box value means minus 0.0001. So it is almost touching 0. So what is the the greatest integer value here? It is -1, right? So this value will be -1, because what does the greatest integer suggest? The greatest integer suggests that the integer value less than the x value. That is the meaning of greatest integer function. Nearest integer less than or equal to x. So if this is -0.001, which is the nearest integer less than this? -1. Please understand this. This is important. The integer less than this particular -0.001 will be -1. So I am writing -1 here. X approaching 0. Limit of a constant is constant. Next, x greater than 0. So x greater than 0 will be coming from this side. So I am coming from this side. So that means I am almost touching 0. So let me take this point. So what will be this point? 0.0001. So what is the box value of 0.001? So integer less than that. So which is the integer less than that? 0. So limit of 0, x approaching 0 will be 0. So we can write left hand side not equal to right hand side. Function is not continuous at x equal to 0. Similarly, at other integer points also f of x is not continuous. Rolle's theorem cannot be applied. Understand this. This is important. You can take any value. You can take 1 also. What if I take 1? So what will be the left hand limit if I take 1? So 0.999. So left hand limit will be box value of 0.999, 0. Right hand limit. 1.00001. So what is the box value of that? 1. So 0 is not equal to 1, left hand limit is not equal to right hand limit. This is the logic of greatest integer function. So one more question. F of x is equal to polynomial function, quadratic function, x belonging to 1 comma 2. So you write step 1, given polynomial function in bracket quadratic is continuous and differentiable in the given interval. We have no issue with this. What will be the step 2? Verify f of a is equal to f of b. So what is the a value? 1, b value 2. Take f of x, f of 1, f of a value will be equal to f of 1, which is 1 square minus 1. The answer is 0. F of b value will be f of 2, 4 minus 1, which is 3. So obviously f of a not equal to f of b, Rolle's theorem cannot be applied, or Rolle's theorem invalid, is invalid. So you can stop here, no need to go to step 3 because Rolle's theorem is rejected at this stage only. Students, now we arrive at mean value theorem, very important theorem in differentiation. Mean value theorem, MVT, or Lagrange's mean value theorem. It is named after the mathematician Lagrange. Lagrange's mean value theorem, LMVT. So what it states? It states that if a function f of x is continuous in closed bracket AB, differentiable in open bracket AB, there exists a value c belonging to open bracket AB such that f dash c is equal to f of b minus f of a divided by b minus a. Here no need of that condition which we had in Rolle's theorem. This condition is not there. F of a is equal to f of b is not required here in mean value theorem. It is required only in Rolle's theorem. So now what is the meaning of this? So let us understand this theorem first. Let me graphically tell you what is the meaning of this. First I will tell you what it states directly, then I will go for the proof of that. Let us say this is your xy axis. A and b can be anywhere, does not matter. So let me take a here, let me take b here, does not matter. So this is your a, this point is your b. Fair enough. Now what this states? It states that I will write a secant here. This is the secant joining a and b. Okay, this is the secant. It can pass anywhere. Don't think that it is passing through 0. No, that is not required. It can pass anywhere it wants, doesn't matter. So this is the secant. Now I have the point C in between, which is parallel to the secant. So let me write a parallel tangent here. Take this point, draw the tangent. Yes. So this is the secant, this is the tangent. If you just observe, this secant is theta. If this is making theta, the angle with the x-axis, because both are parallel, this is also theta, we can consider. So that means the slope of this is equal to slope of this. So this particular formula gives slope of the secant. Indirectly, it is giving us slope of the tangent at the point C. This is your point C, students. This is your point C. Okay. So, we have a secant passing through A and B. We have the tangent parallel to the secant at point C, which is given by this formula. Fair enough. Now, how do we arrive at this? I'll give you, though this is not so important for your board exam, they will not ask you the derivation, but it is good to know. It's good you know this. See, let me have the graph like this. Yeah, let us say this is the graph. Let us say I have a secant here. Yeah, this is the point A, this is the point B. Now, students, if I write one line which is parallel to the x-axis, this angle and this angle are same, you know it, because they are the corresponding angles. If this is theta, this will be theta, because both lines are parallel to each other. Now, please observe here carefully. Tan theta, let me name it as A, B, C. Tan theta is nothing but opposite AB by adjacent BC. Fair enough. Now, students, if you just observe AB, let me call it as M, let me call it as N. Your AB can be written as AM minus AB, AM minus BM. AM minus BM is your AB, this value. Similarly, BC value is nothing but, this is origin, OM minus ON. Fair enough. OM, distance till here, minus this, that will give you this value. Now, students, what is this AM, the vertical value? The vertical value of AM is nothing but f of B minus BM and CN are same. BM and CN are same. So, what is the value of CN? F of A. The vertical value will be f of A divided by, so OM. So, O to M, what is the distance? B minus ON is A. So, I am getting the answer as tan theta is equal to f of B minus f of A divided by B minus A. Basically, this tan theta represents slope of secant. Slope of secant. Now, as I told you, what if I draw a tangent parallel to the secant at this point? I am going to draw a tangent parallel to the secant. Let me draw that. This is the tangent. Because the angles are equal, if this is theta, this will be theta, the slopes are also equal. So, I can conclude this is the slope of the secant, which is also nothing but slope of tangent at C. So, this value is my C. So, what we are doing here, basically we are telling the slope of the secant is this formula which I have proved here. Also, we are telling the slope of the secant and tangent are equal. So, it gives me indirectly the slope of the tangent at this point C, given by this formula. For your exam sake, you have to write this graph only. This graph is for your understanding sake, but it is better you understand and take down the graph. Okay, take down the problem, students. Verify MVT, mean value theorem, for the given function. This is the quadratic function. So we will write the step 1. Step 1 will be as it is, what we were writing in the Rolle's theorem. Given polynomial function in bracket quadratic function is continuous and differentiable in the given interval. This is the number 1. Number 2, find f dash x. No need of f of a is equal to f of b in mean value theorem. So find f dash x. F dash x is given by 2x minus 4. So f dash c is given by 2c minus 4. This is your step 2. Step 3, apply the formula, students. Apply the formula directly. F dash c is equal to f of b minus f of a divided by b minus a. Apply this formula. So 2c minus 4 will give me, so what is f of b? So let us find out separately. F of b is equal to f of 4. So f of x is given by this quadratic. So f of b, f of 4, 4 square minus 16 minus 3. So I am getting minus 3 as f of b. F of a, f of 1, 1 minus 4 minus 3 minus 6 I am getting. Substitute the values. F of b is minus 3. This is minus 6 divided by b minus a, 4 minus 1. Solve this fast. 2c minus 4 will give me minus 3 plus 6 by 3. So 2c minus 4 is giving me 6 minus 3 will be 3 by 3. So 2c minus 4 is equal to 1. 2c is equal to 4 plus 1, 5. C is equal to 5 by 2. 5 by 2 you can represent it as 2.5. Always better. So which belongs to the interval, given interval. So 1 comma 4.